Hello friends, this is Rashmi Singh and welcome to my channel Unraveling Science. Solutions for Gravitation, Class 9, Chapter 9. In-text questions. First, state the universal law of gravitation. According to this law, every object in the universe attract each other with some force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. As you can see in the picture, it is given by F is equals to G m1 m2 upon d square, where G is the gravitation constant whose value is 6.67 into 10 to the power minus 11 Newton meter square per kg square. Write the formula to find the magnitude of the gravitational force between the earth and an object on the surface of the earth. So let m, the mass of the earth, mass of the object on its surface is small m, radius of the earth is r. According to universal law of gravitation, the gravitational force acting between the earth and the object is given by the relation F is equals to G capital M multiplied by small m upon r square. What do you mean by free fall? Gravity of an earth attracts every object towards its center. When its object is dropped from the certain height, it begins to fall towards the earth's surface under the influence of gravitational force. Such a motion of an object is called free fall. What do you mean by acceleration due to gravity? When an object falls freely towards the surface of the earth from a certain height, then its velocity changes. The change in velocity produces acceleration in the object, which is known as acceleration due to gravity. It is denoted by letter G and its value is 9.8 meter per second square. What is the difference between the mass of an object and its weight? The difference between the mass and the weight of an object is mass is the quantity of matter contained in the body. Weight is the force of the gravity acting on the body. Mass is the measure of inertia of the body. Weight is the measure of gravity. Mass is a constant quantity. Weight is not a constant quantity. It is different in different places. Mass has only magnitude. Weight has both magnitude as well as direction. The SI unit of mass is kilograms. The SI unit of weight is Newton. Why is the weight of an object on the moon is 1/6 of its weight on the earth? The mass of moon is 100 times and its radius is 1/4 times that of the earth. As a result, the gravitational pull on the moon is about 1/6 as compared to the earth. Hence, the weight of the object on the moon is 1/6 of its weight on the earth. Why is it difficult to hold a school bag having a strap made up of thin and strong string? It is difficult to hold a school bag having a thin strap because the pressure of the shoulder is quite large. This is because the pressure is inversely proportional to the surface area on which the force acts. The smaller the surface area, the larger will be the pressure on the surface. In this case, a thin strap, the contact surface area is very small and pressure exerted on the shoulders is very large. What do you mean by buoyancy? The upward force exerted by a liquid on an object that is immersed in it is known as buoyancy. Why does an object float or sink when placed on the surface of the water? An object sinks in water when its density is higher than that of water. An object floats in water when its density is lower than that of water. You find your mass to be 42 grams on weighing machine. Is your mass more or less than 42 kgs? When we weigh our body, an upward force acts on it. This upward force is the buoyant force. As a result, the body gets pushed to slightly upward, causing the weighing machine to show a reading less than the actual value. You have a bag of cotton and iron bar, each indicating a mass of 100 grams when measured on the weighing machine. In reality, one is heavier than the other. Can you say which one is heavier and why? The bag of cotton would actually be heavier than the iron bars when measured in air because the cotton, due to its lower density, takes up more volume and displaces more air, resulting in large buoyant force acting on it as compared to iron bars. This means that due to greater upward buoyant force of air acting on the cotton bag, the weighing machine will show a much lesser mass of cotton than that of iron. So, in reality, 100 grams of cotton weighing in air will be heavier than 100 grams of iron weighed in air. Back exercises. How does the force of gravitation between two objects change when the distance between them is reduced to half? According to universal law of gravitation, the force of attraction between two bodies is F is equals to G m1 into m2 upon r square, where m1 m2 are the masses of the two bodies, G is the gravitational constant, and r is the distance between the two bodies. If the distance is reduced to half, which means r is equals to 1 by 2r, therefore, putting the value of r in the equation, we get the new force will be 4 times the original force. Hence, if the distance is reduced, then the gravitational force will become 4 times larger than the previous value. Gravitational force acts on all objects in proportion to their masses. Why then a heavy object does not fall faster than the lighter object? All objects fall on ground with constant acceleration called acceleration due to gravity in the absence of air resistances. It is constant and does not depend upon the mass of the object. Hence, heavy objects do not fall faster than the lighter objects. What is the magnitude of the gravitational force between the Earth and 1 kg object on its surface? The mass of the Earth is 6 into 10 to the power 24 kgs. Radius of Earth is 6.4 into 10 to the power 6 meters. Now here given the mass of a body is 1 kg. Mass of Earth is 6 into 10 to the power 24 kgs. Radius of the Earth 6.4 into 10 to the power 6 meters. So magnitude of gravitational force will be, putting all the values in the given equation, we can get the force 9.8 newtons approximately. The Earth and the Moon are attracted to each other by gravitational force. Does the Earth attracts the Moon with the force that is greater or smaller or same as the force with which the Moon attracts the Earth, and why? According to universal law of gravitation, two bodies attract each other with equal force but in opposite directions. So Earth attracts the Moon with same force with which the Moon attracts the Earth. If the Moon attracts the Earth, why does the Earth not move towards the Moon? The Earth and the Moon experiences equal gravitational forces from each other. However, the mass of Earth is much larger than the mass of the Moon. Hence, it accelerates at a rate lesser than the acceleration rate of the Moon towards the Earth. For this reason, Earth does not move towards the Moon. What happens to the force between the two objects if the mass of one object is doubled The distance between the objects is doubled and tripled. The masses of both objects are doubled. So from universal law of gravitation, force exerted on an object of mass m by Earth is given by F is equals to G, product of the masses upon r square. When mass m of an object is doubled, that is m becomes 2m, then putting the values of nu m in the given equation, we get mass of one of the object is doubled, then the force is also doubled. The force is inversely proportional to the distance between the objects. So, if the distance between the two objects is doubled, then the gravitational force of attraction between them is reduced to 1/4 of its original value. Similarly, if the distance between the two objects is tripled, then the gravitational force of attraction becomes 1/9 of the original value. Force is directly proportional to the product of both the masses. So, if both the masses are doubled, then the gravitational force of attraction becomes 4 times the original value. What is the importance of universal law of gravitation? Universal law of gravitation is important because it tells us about, first, the force that is responsible for binding us to Earth. Second, the motion of moon around the Earth. Third, the motion of planets around the sun. And fourth, the tides formed by rising and falling of water levels in the oceans are due to gravitational force exerted by both sun and moon on the Earth. What is acceleration of free fall? Acceleration of free fall is the acceleration produced when a body falls under the influence of force of gravitation of Earth alone. It is denoted by g and its value on the surface of the Earth is 9.8 meter per second square. What do we call the gravitational force between the Earth and an object? Gravitational force between the Earth and the object is known as weight of the object, which is given by mass into acceleration due to gravity. Amit buys a few grams of gold at the poles as per the instruction of one of his friends. He hands over the same when he meets him at the equator. Will the friend agree with the weight of gold bought? If not, why? Hint, the value of G is greater at the poles than at the equator. So, weight of the body on Earth is given by weight into mass into acceleration due to gravity. So, the value of G is greater at the poles than at the equator. Therefore, gold at the equator weighs less at the poles. Less than at the poles. Hence, Amit's friend will not agree with the weight of the gold bought. Why will a sheet of paper fall slower than one that is crumbled into a ball? The surface area of the crumbled paper is smaller than that of the sheet of paper. Therefore, there will be a lot of air resistance for a sheet of paper. That's why the sheet of paper falls slower than the crumbled paper ball. Gravitational force on the surface of the moon is only 1/6 as strong as gravitational force on the Earth. What is the weight in newtons of a 10 kg object on the moon and on the Earth? Weight of an object on the moon is 1/6 of weight of the object on the Earth. So, we know that weight is equals to mass into acceleration due to gravity. Acceleration due to gravity, G is given by 9.8 meter per second square. Therefore, weight of a 10 kg object on the Earth is 10 multiplied by 9.8, that is 98 newtons. Weight of same object on the moon is 10 multiplied by 1/6 of 9.8, which is 16.3 newtons. A ball is thrown vertically upwards with a velocity of 49 meter per second. Calculate the maximum height to which it rises. The total time it takes to return to the surface of the Earth. Given initial velocity is 49 meter per second, final velocity at maximum height is 0. Acceleration due to gravity is minus 9.8 meter per second square. It is negative because ball is thrown upward against gravity according to third equation of motion. That is 2gh is equals to v square minus u square. Now putting all the values in the given equation, we can find the height, which is 122.5 meters. Now let time be taken be t by the ball to reach the height of 122.5 meters. So according to the first equation of motion, putting all the values in the given equation, we get the time, which is equals to 5 seconds. Also, time of ascent is equal to time of descent. So the total time will be time of ascent plus time of descent. That means 5 plus 5, time is 10 seconds. A stone is released from the top of the tower of height 19.6 meters. Calculate its final velocity just before touching the ground. Now, given the initial velocity here is 0, final velocity of the stone is v. Height of the stone is given 19.6 meters. Acceleration due to gravity is 9.8 meter per second square. So according to third equation of motion, v square minus u square is equals to 2gh. Putting all the values in the given equation, we can calculate the final velocity, which is equals to 19.6 meter per second. A stone is thrown vertically upward with an initial velocity of 40 meter per second. Taking acceleration due to gravity as 10, find the maximum height reached by the stone and what is the net displacement and total distance covered by the stone. Here, given the initial velocity is 40 meter per second, final velocity after reaching the maximum height is 0. Acceleration due to gravity is minus 10 because the stone is thrown upward against gravity. So height will be according to the equation of motion, we putting all the values in the given equation, we get the height, which is equals to 80 meters, which is the maximum height reached by the stone. Total distance covered by the stone will be upward distance plus the downward distance, that is 80 plus 80, which is 160 meters. Net displacement of the stone will be 80 plus minus 80, that is 0. Calculate the force of gravitation between the earth and the sun, given that the mass of the earth is 6 into 10 to the power 24 kgs and of that of sun is 2 into 10 to the power 30 kg. Average distance is 1.5 into 10 to the power 11 meters. Now here the mass of the sun is given 2 into 10 to the power 30 kgs. Mass of earth is 6 into 10 to the power 24 kgs. Distance between the earth and the sun is 1.5 into 10 to the power 11 meters. Now from universal law of gravitation, putting all the values here, where g is 6.67 into 10 to the power minus 11, we get the force 3.56 into 10 to the power 22 newtons. A stone is allowed to fall from the top of the tower, which is 100 meters high, and at the same time another stone is projected vertically upwards from the ground with a velocity of 25 meter per second. Calculate when and where the two stones will meet. So when the stone is thrown from the top of the tower, its initial velocity is 0. Distance travelled is, let us assume x. Time taken, we assume t. Acceleration due to gravity is 10 meter per second square. So s is equals to ut plus half gt square. So putting the values here, we get x is equals to 5t to the power 2, which is the first equation. When the stone is thrown upwards, Then the initial velocity is 25 meter per second. The distance traveled is 100 minus x. Time taken here is t. Again putting all the values in the same equation, we get x is equals to 100 minus 25t plus 5t square. That is equation B. Now from both the equation A and B, we get 5t square is equals to 100 minus 25t plus 5t square. So 5t square is cancelled and we get t's value 4 seconds. The two stones will meet after 4 seconds. From equation A, which is x is equals to 5t square, putting the value of t here, we get the distance 80 meters. Now putting the values of x in 100 minus x, we get 100 minus 80, that is 20 meters. This means that the two stones will meet after 4 seconds at a distance of 20 meters from the ground. A ball thrown up vertically returns to the thrower after 6 seconds. Find the velocity with which it was thrown up, the maximum height it reaches, and its position after 4 seconds. Time of ascent is equals to time of descent. So the ball takes total 6 seconds for upward and downward journey. Hence, it has taken 3 seconds to attain the maximum height. Final velocity of the ball at the maximum height is 0. Acceleration due to gravity minus 9.8 meter per second square. Now we know that v is equals to u plus gt. Putting all the values over here, we can get the initial velocity, which is equals to 9.8 into 3, that is 29.4 meter per second. Hence the ball was thrown upwards with a velocity of 29.4 meter per second. Let maximum height attained by the ball be h. Initial velocity during upward journey is 29.4 meter per second. Final velocity is 0. Acceleration due to gravity minus 9.8 meter per second square. So from equation h is equals to ut plus half gt square, putting all the values over here, we get the height 44.1 meters. Now ball attains the maximum height after 3 seconds. After attaining its height, it will start falling downwards. In this case, initial velocity is u. Position of the ball after 4 seconds of throw is given by the distance travelled by it during its downward journey, that is 4 seconds minus 3 seconds is equals to 1 second. So again putting the values over in here, we get the height 4.9 meters. Now the total height will be 44.1 meters. After 4 seconds, the ball is 44.1 minus 4.9, that is 39.2 meters above the ground. In what direction does the buoyant force on the object immersed in a liquid acts? An object immersed in a liquid experiences buoyant force in the upward direction. Why does a block of plastic released underwater comes up to the surface of the water? For an object immersed in water, there are two forces which acts on it. First is gravitational force, which tends to pull the object in downwards direction. And the next is buoyant force that pushes the object in the upward direction. In this case, the density of plastic block is less than that of water, hence the buoyant force is greater than the gravitational pull on the plastic ball. This is the reason why it floats on the surface. The volume of 50 grams of a substance is 20 centimeter cube. If the density of water is 1 gram per centimeter cube, will the substance float or sink? If the density of an object is greater than the density of liquid, then it will sink in the liquid. If the density of the object is less than the density of liquid, then it will float in the liquid. We know that density is equals to mass upon volume. So 50 upon 20 will be 2.5 grams per centimeter cube. Here the density of substance is more than that of the density of water, which is 1 gram per centimeter cube. Hence the substance will sink in water. A volume of 500 gram seal pack is 350 centimeter cube. Will the packet float or sink in water? If the density of water is 1 gram per centimeter cube, what will be the mass of the water displaced by this packet? So the density of the seal package is mass upon volume, that is 500 upon 350, which is equals to 1.428 gram per centimeter cube. Here the density of the substance is more than that of the water, that which is 1 gram per centimeter cube, so it will sink in water. The mass of the water displaced by the packet is equal to the volume of the packet, which is 350 grams. Thanks for watching. Please do like, share and subscribe.